Alright, I'm going to set a stroker sportster cylinders here. Get these things done. So these are the ones I welded up last month. I welded up the drain holes and drilled new ones. Now I got to go back and drill these again. And in case the brass went down into there. Can't tell. So we're going to drill a bit through it. And these are the pistons we're going to pull the cylinders for. So the first thing I do is get ready to do some drilling. Alright. So first thing I do right now is figure out what drill size I got in here. So that's kind of important. So I go through my drill index and find the one that fits in the hole here. So it is not 154. It's less than that. What would that look like? I'm thinking 154 will be just fine. I probably used 1/8 of an inch or something. Let's see, here is a 128. Nope, we're bigger than that. There's one we used. We used 144. So this is 10 thou bigger. I'd like to get up to 3/16. I'm not sure if I want to go how much gasket area I got, but I think I'm good on that. So it'll go a little bit bigger than that. Here's 160. I think I can push 160. This is our thinnest one right here. Everybody else is bigger. So this is the one here where you lose the gasket surface right here. So it gets kind of thin. All the other ones I think I can go up to 3/16 with no problem. See, it's a real thick area. And this side here, they're both thick, so no problem. So I can probably go to 3/16 on this one. You can see how big the hole is here. They're pretty good size. Alright, so this one's going to be 160 thou. Let's see what happens here. Down to, we're going about full depth to get through the brass. Alright, see what happens here. If you break a drill bit off, we're screwed. No breaking drill bit. Brass chips are coming up now. See where they're coming up to the top here. Good view. I'm drilling through solid brass. Keep light pressure on it. It's starting to go through. There we go through. Obviously bigger once I go through. The hole on the other side is obviously bigger. Okay, now we blow this off, see what we got. there's what we got now. Looks pretty good. Okay, that was the easy one. This one here is the one that's going to be real thin. See what happens with this one. Nice and slow, so we're going to dig in. The drill bit digs in, it'll go in like a screw and auger itself straight down. There's the brass. Starting to go through. There it goes. Yeah. Okay, so now we got the hole all the way through. Obviously no problem with that one. So let's see what a 3/16 looks like. Let's see, 180. This is just right at 3/16, 189. Obviously it's a lot bigger than that, these drain holes. Pushed up to 200. It's getting close to the real size. Nice video. The drill went away. So that's close to what the actual hole size is. Probably another 5 thou bigger than that at least. Okay, so I think on the ones right here where we got a lot of meat, I can put this bigger one in here with no problem. So I'm going to go ahead and change up the bit to this one. Small one goes back. Burrs on there. Burrs keep it from going back in the drill index. See the burr? There we go. Okay, I'm going to try the bigger hole here again. Not that one. This one over here. See what this one does. Okay. See if we can snap something off here. Going in the old hole. Wasn't happy there, was it? Alright. Alright, now we got a nice big hole in there now. The difference between that one and this one, see? Gasket goes way out here, so it shouldn't be a problem. At least I hope it does. Alright, there's that one. Actually, I better go get me a gasket and double check that, because it looked like it might not be as thick as I thought. It's not going to be this thick, I bet. Yeah, probably not. Let me get a gasket. Be back. Alright, we're back. So here's the gasket. So that's how thick the gasket is. It's always nice to double check this stuff before you get too carried away. I think I'm safe on that one. Looks like a lot of meat. This one over here I'm not so sure about, so. Yeah. Goes that way. So this one we got a lot of meat. This one over here, not so much. Thick flange, but no meat. Oop, over there. So this one's a little bit thinner on this one here, obviously. This is on the exhaust side, it looks like. This one was repaired. Brand new cylinder's been repaired. Huh, wonderful. You see it on your blast the paint off, you see all the damage hidden. Oh well. Alright, so the this one here is probably alright to be the thick one. It's going to be way over here though. I think I'll drop it back just a little bit though. This one obviously no problem. This one, I don't think so. I think I'll go about 180 on that one. We'll pull back a little bit. Alright, so each one of these is a different hole size just about. Make sure you leave enough material for not leaking. Okay, so this is our thick side. I'll put the big hole in this one. Quick drill and answer when we hit it. Alright. Take out the 200, go to something smaller. And we'll drop back to 182. So we got 160, 180, and two of them at 200. There you go. Nice even numbers. Got a gas material still there, we're good. A lot of frost in that one. Alright. Okay, so now we can see we got this coming out, look good. Alright, so that's 20 thou smaller, but it's not too awful smaller than that big one. The biggest thing is the drill goes in there that deep, that size. There's no restriction coming past it. Should be a good flow coming up through. This is our most restricted hole, which is what we're going to live with. That is on the intake for the front cylinder. This one, the small hole, is on the intake of the rear cylinder. So the exhaust has big flow on both, so that's good. Heads are angled like that, so most of the foil goes down. Alright, so we got that part handled. Now we get to tackle the piston part. 180. Okay, these have to be bored now because we got the brass in the hole. I can't just hone them. That's why they give them. That's why they want to make stroker pistons in 10 over. That's your first size, because you know you have to do this work to the cylinders. Okay, get this out of my way a little bit. Alright, so we got to figure out what the bore these are. Trying to protect them. Yeah, they fitted them. Racing fit. Nice and loose. Just like they're supposed to be. Feel lighter than they used to be for some reason. Nice high dome. They haven't lowered it down yet, like all the other motors did. Old mic. Okay. So it looks like they're 5 thou under standard, maybe 4. Okay, so let's see what the pistons are here. So you're going to mic these things. So the way I mic a piston is you measure it on the thrust face, because these things are actually oval shaped. They're actually shaped like this. So when they warm up they get round, when they're cold they're like this. So you measure right here on the thrust face. Usually these old pistons you measure at the very tip, other ones you measure a ½ inch down. Depends on the manufacturer. Either way you want to make sure you got some taper to it. We got about 3 thou taper. That's good. 2. This is a tick smaller. Yeah, it's a third of a thou smaller. Yeah, so much for being on same size. Yeah, it's definitely the big one. Modern engineering and machinery. They still can't make both pistons the same. So this one here is the big one. That'd be B. It's a small one. BS. Also put it over here. S. B. Maybe it's BS. Could be. Alright. Pull out the propaganda and see what side the piston is supposed to be set up. This looks like it's all about rings and not about piston bore size. Oh, seats on the back. Ooh. There we go. These are 1065539. 10655 29. There's 39 at 79. I have a 39. Great. Means we're on our own, huh? So we got standard through 40. That's a shovel head piston. Yep, there's some other numbers, 36, 37, 38. Shit, pick the number again. Be nice if these things are order. Got close, got one number off. That's it. Let's see, 7/16 is ½ inch, 7/16. These are all 7s, 5/8, 5/8. There's a 3/16. 42 is the number. Yeah, they're sneaky bastards. That says 39, right? Piston kit's 42. That's stupid. Fucking stupid S&S. So 42 is 39. That morons. Yeah, way over here, they got it over here. See, this is part number. This is part number. Two different part numbers, same part. Nice. Alright, they're saying 3.5 to 4 or 4.5 to 5.5. 3.5 is your stock clearance on Sportsters. I think this guy said he's going to run the snot out of it. So we're going to make at least 3 3/4 to 4. That way we can run the piss out of it. We like that around here. So basically that means I bore the cylinder to what the piston is, and then I can hone it to size. So we're at 197.5. We'll bore at 97. That would be 3.197. There's no spurs on it. Okay, so I'm ready to go in the boring bar. That'd be that thing over there. First thing is get the mill out of the way. The mill is in the way. So there's everything else that's on the floor. All that crap. Okay, you gotta clean off your table because it's full of mill chips. That happens when you use your mill. Alright. Got a head knocker up here, gotta move out of the way. All kinds of obstacles to get around. Now this is a big bore over here for up to 4-inch bores. This is a small bore over here for sportsters and flatheads. Flathead to be in 45s. Wipe off our tools. Important your tools are clean. Probably can't use that one. Too long. All right. Alright, goes over there now. We'll change out our fingers probably. Let's see, what do we got here? Threes. Yes. These are big ones. These are real long. So you go up to your chart up here. Too many people have these charts anymore. So we're at number 5 when you drop back to number 4. So these are 5. Now I color code mine so I know where they go. Because every time you put a different spot in the bar, it changes the center location. Okay. So we want number 3s. 2s, 3s. No, we want number 4s. 4s are right there. 4 is this one. These down here. 2s. 2s are for small bores. 45 motors. Alright, so we want number 4s. These are our 4s. 4s are 3120 to 3480. So these will do Sportsters and 74-inch motors only. Not big bore ones either. Okay, I'm going to wipe these all off. Put them inside the holes down here. And those expand out in the center of the cylinder. Clean these off. And they came out of a clean box. Clean them anyway. Don't lose them either when they're trying to run away. Alright, what do we got? Number 2. Number 2 is a black one for me. Red one. And that's the one that's natural. Okay, now we need a cylinder. This goes up with a jack down here in the bottom. Now when you jack, you want to make sure you jack on top where the cylinder is, not off the side. The table tilts like this if you do. So you have to move this over a little bit. Should be a mark over here someplace. There's a couple of them over there. I like that one right there. Okay, and we jack it up until the cylinder goes up in the table up here. Sure everything's where you want it to be. It looks centered. A little pressure on it, not too bad. Make sure it's tight. Feels good. Okay, now we expand these fingers out. So you can run the table down. Now you want these fingers to be toward the bottom of the cylinder so it squares way down here, not at the very top. Ideally you want to be about halfway. It usually works best if you turn this thing 90, turn it over to here, 180 degrees from where you're at. Okay. As you go down until I can feel it on the bottom under here. It's a good spot to be. It's about 3/4 of the way down. You tighten the screw up here. Those fingers go in a cone, taper. This pulls the cone up, which expands them out and makes them tight. That's what centers the boring bar. Right now the boring bar can slide around, see? You tighten this up, see how the bar goes over? Then I go up and down a little bit just to kind of make sure it's clean where it's at. Loosen it up a little bit. Come back, do it again. Tighten up just a little bit up here, not super tight, just a little bit. And there's a wedge bolt over here that tightens it up right here. This bar is nice and tight right now. One. That's enough pressure. Doesn't take a lot. Okay, so everything's locked in now. Now you undo the clamp up here, takes the pressure off those fingers. And normally I just power up, but I got those brass down in there right now. I don't want to power those brass parts, so I'm just going to hand crank it back up. This. Make sure the fingers don't hit anything. Yep, they look good. Good to go. Now we got to set our thing. Make sure these are all the way in. Go. Belt feels pretty old up there. It's definitely got a high spot on it. It's sitting too long. Okay, we got to clean out the hole right here. That's where the micrometer goes in at. So you go in here and clean the brush. Oop. Clean this out like this. Make sure it's all clean. Good to go. Okay, now the micrometer here sets the bore, so we have to set this to the size we want. Looks like right now it's around 3.5 inches. I'm going to drop that back a little bit. I'm going to wind up using a shorter tool. This one's for bigger bore cylinders, this is for small bore stuff. That switches over, depending where I got adjusted at. Could be anywhere from under 3 7/16 to up to 3.8 inches. Depends on where I got it set at. Okay, I wipe off this one here. Make sure nobody's dropped my bit. Looks pretty sharp still. Looks alright. Got a little wear on it, not too bad. See how it works. Putting it straight would help. There it goes. There's a spring on it, see? Make sure the spring is going to get me past where I want to be. It is. Okay, so now I'm going to set the mic. Clean the oil off a little bit. Okay, so I'm going to back this off. 200. Let's see, 3.5. Each turn is 50 thou, so it's just like a regular micrometer. 1, 2. There's 3. Yeah, we'll be a little bit under it, so I can clean up the new cylinder. We should be about 35 is what it's at right now. I'll give it a couple extra thou. That should just cut the inside of the cylinder with the bolts in it. Always like doing that to see if everything looks like it's square. Wipe everything off real good, make sure there's no dirt on it. Now this is where it goes in and stops. This the indent here puts pressure on the ball indent. This is what controls how deep it goes. Spring tension pushes it up against the stop. Then you just lock it down with the set screw. Not a ton of pressure, but a little bit. You pull it straight off, don't rotate it because the carbides are up next to it. You can see all the years of it beating on the side of it here. Now we go down and see if it looks like it's going to cut. Looks like the dumbass set the mic wrong. Yeah. $400, $300. Well, looks like it's good to me. Obviously it's not. Of course this dark hole I'm looking at doesn't help. Alright. Yeah. Obviously I'm not doing the right thing because it's bullshit where it's at. What am I reading? My eyes are getting bad, I guess. These non-highlighted mics are hard to read. Shouldn't look like it was that far off. Okay, that's 0. 50, 1, 150. Couple extra. Should be right there. Yep, off by one turn. Yep. Better be low than much, too much, right? Yep, it's going to just cut. Make sure it clears everything. Look around and see what happens. The depth stop right here. That'll work too much. Glass out. Yeah, it's getting rounder down there. That's where I centered that. This needs to be dropped down a little bit. It's been too many years since I used this much, so I don't remember exactly what the depth stops are. I've got all these codes on here. Comes out the bottom, you went too far. You want to make sure you're flat against the surface up here. That chip. Push this button down and shut it off and it's out there. See it yet. Another 4 inches to go. No, not the right spot. There it is. All the way through now. Stop in a minute. There we stop. And go up. All right. Now you can see how round the cylinder was. See the low spot back there. It was just barely cutting there, then a low spot cutting right there. See the brass right there. It was cutting all the way around the rest of it. Look down the bottom of the hole. It started cleaning about just below my finger on this side. You can see what it eyebrows up. And you look on the rest of the cylinder, see if it's clean all the way around. Much as I can see in there, it looks good. Alright, and there's the brass right there. This one has no porosity in it. This one here, it's got some porosity in there, it looks like. Alright, so now I got to measure it, see what the bore size is. See what we got. Okay, we're certain for 98 is what we're looking for. Gonna set this mic to match this mic. Mics never match each other. Look too far finally. Yeah, this one's way different. Okay, so this mic here is going to be, it's about a half over 0, so we just call 0 is what we're looking for. So let's go see what size the cylinder actually cut to. It didn't fall through, that's a good sign. Fingers are getting too big to go in there. Okay, we got 15, so we got 10 more thou to go. So we're cut for standard right now. So that means we didn't cut very much out. So I got 10 thousandths to go. So we set this for 10, which would be 98. Right there. That should cut me right the size I want. Everything all off. Cutter in there. It'll pop out. We're good to go for another shot. Set the mic for where I want to be at. Go in a little bit and check to see what size it really is. Just got light pressure on it. Perfect. That's where I want it to be. Okay, that was just a double check. It's good. So now I'm going to let it blow all the way through. Blow it straight down, it'll be good. Cut line down there. Just dropping. All right. We're blowing down. Not that much to go. And we can see the other cylinder. Do the same thing with this cylinder. Then we get to do some coating. I mean, not coating, honing. Get to hone it. So I guess if the customer wants me to paint these, I'll coat them. I forgot. So if I'm going to coat them, I'm going to do the coating before I hone it. If I'm just going to paint it, I'll go ahead and do all the final work and then paint it. So we'll see what the customer wants, because I don't remember. It's been too long. Anyway, we'll figure it out. I'm just going to pull it out of here in a couple more minutes. It's about 5 minutes to make a pass, 4 to 5 minutes to recall. New cylinder's cut nice and clean. No hot spots, hard spots, anything there. Except for the brass. Really burned through that though. We're leaving about 4 to 4.5 for honing. Plenty neat. We got good clean metal. There we go. Yep, off through right there. Good stop. Feed shuts off, but not the power. Okay, bring that around. Take our mic and check the bore again just to make sure nothing stupid happened. Like it falls through like it just did. There we go. You had to give it a 1/2 thou to make it real tight. It bored about a 1/4 thou than expected, but I was still a 1/2 on the good side anyway, on top of the 4. Alright, pull that out. Now you just pull the cylinder out. Drop the jack down. Pull the cylinder out. Clean it off. Get all the crap off of it. Alright. So there's the cylinder all done. That's why you bone after you bore. See, the bore leaves a kind of a semi-crappy finish. That bit's getting dull, I think. So you don't get so much unevenness to it. You can feel a bit of differences in there. Time for a sharpening job, maybe. So there's that one. This one don't have much porosity on it, so just a couple of small pieces I can see. This one looks a little bit right there, so that's clean weld. So good weld. The rings don't really get down this far anyway, so it doesn't really matter. The oil ring just touches this. It might go about halfway to it at most. That's all we'll get down to it. But not too critical. Okay, so that one's done. I'll go put this one, do this one, and we'll see what's going to happen to the rest of it from there. That's it for now.